Okay, so back here with number 3, the first non-calculator one. So first thing is, we've seen setups like this, say g is defined from -4 to 8, consists of all this stuff, and let f be defined as a function, equal to some sort of g. This one's harder, and that's okay. If it's harder for you, it's going to be harder for everyone else, so we're not really rooting for easy problems. The difference here is this 3x. So if I take the derivative here, instead of getting just g of x, I get 3 plus g of x. So that means this is not a picture of f's derivative. We would have to shift this whole graph 3 places up to draw f's derivative. So they ask us for f of 7 and f prime of 7. So f of 7 is 3 times 7 plus the integral from 0 to 7 of g of t. So obviously we get a 21 right here. And then if we're doing the integral from 0 to 7, we're going to take this area, which is a circle with radius 3, but it's half of it. So this will be 9 pi over 2. That'll count negative because it's underneath the x-axis, and then we're only going to 7, so we'll count those 3. So I get 21 plus negative 9 pi over 2 plus 3, so I get 24 minus 9 pi over 2 for f of 7. F prime of 7, if you take the derivative, we said we get 3 plus g of x, so we'll get 3 plus g of 7. And g of 7 is equal to 3, so we'll get 3 plus 3 to get a value of 6 for f prime of 7, okay? And it says find the value on the closed interval where f attains its maximum value. So I drew a picture of f prime, so I just shifted this whole graph up 3 spaces. And when I did that, I noticed that it was always above the x-axis, which means f prime is always positive, which means f will take its max at the end, and I'll just say that. I'll say since f prime is never negative, f will have its biggest value at the end of the interval, which is at x equals 8. Everybody okay with that? Oh, sorry, it says from -4 to 3, so f will have its biggest interval or biggest value at 3. If it had been over the whole interval, it would have been at 8. All right, part C says find the limit for g prime of x, and from g prime of x as x approaches 0 from the left, and g prime of x as x approaches 0 from the right. So if I look at the picture, they're just asking what the slopes are approaching as I approach 0 from the left. So as I approach 0 from the left, the slopes are just holding steady at -1/2. So I'm going to put that. As I approach 0 from the right, slopes are going more and more and more towards infinity. So I will say that this answer here is -1/2. And I will say that this answer here does not exist. Okay, and then part D says, find the limit of this quantity as x approaches -2. So as I approach -2, if I plug a -2 into here, so I've got my f of x function right here. So f of -2 will equal 3 times -2 plus the integral from 0 to -2 of g of t. So obviously this is a -6. This one I would want to flip around. So if I go back and look at the picture, if I go from -2 to 0, I can't do that without consequence, so I'll go like this. Well, this is quantity here is equal to 1, so with a negative in front of it, I get a -7. So if I go back here, that -7's there, so I get a 0. And then on bottom, if I plug in a -2, I get e to the 0, which is 1 minus 1, which is also 0. So another indeterminate form. Remember, if we have 0 over 0 or infinity over infinity, we can use what's called L'Hopital's rule. L'Hopital's rule says I can just take the derivative of the top and the bottom and try again. So the derivative of the top would be f prime of x. Derivative of the bottom would be 3 e to the 3x plus 6, and I'll try again. So if I'm doing f prime of -2, so we'll recall that f prime is equal to 3 plus g of x. So g of -2 is 1, so 3 plus 1 is 4. If I put a 0 or a -2 in the bottom, I still get a 1 quantity here and a 3, so I get 4/3. And that's the end of that problem.